Hi, in this video I'm going to just define kinetic energy, and we're going to solve a couple of very basic kinetic energy problems. Now, there are many different types of energy, but kinetic energy is probably the most fundamental, most basic. Kinetic energy, we use the variable k for it, or we can sometimes write ke or e sub k. Rarely we use t. But kinetic energy is just energy due to the motion of an object. And so it depends on two variables. It depends on mass. More mass you have, the more kinetic energy you have. And it also depends on how fast you're moving. So it depends on mass and speed. Kinetic energy is a scalar, not a vector, so it doesn't depend on velocity. Our formula for kinetic energy is given right here. Kinetic energy is equal to 1/2 times the mass times the speed squared. And the units for kinetic energy are going to be our units for all energy and work. They're going to be units of joules, Joules. The symbol for a joule is a capital J, 1 joule. And a joule is equal to a kilogram times a meter squared divided by a second squared. Another way of writing joules is a newton times a meter, a unit of force times a unit of distance. So looking at the equation, we can see how the different variables affect kinetic energy. We can see that kinetic energy is proportional to our mass. So if you double the mass or you triple the mass and keep the speed the same, you double or triple the kinetic energy. But interestingly, our kinetic energy isn't proportional to how fast you're moving. It's proportional to speed squared, which means if you double the speed, you're going to quadruple the kinetic energy because you're multiplying it by 2 squared. If you were to triple the speed, that means you have 9 times as much kinetic energy as before. And this is important for things like if you're driving a car. If you're driving twice as fast, it's going to take 4 times as much distance to stop the car, because you have 4 times as much energy. We can sketch a little graph of how kinetic energy changes with speed, and I have one down here. I've labeled a few important points. Obviously at 0 speed there's 0 kinetic energy, but we can see that because it's proportional to speed squared, we get this parabolic shape, something like that. It's not a perfect parabola, but this is kind of our kinetic energy as a function of velocity. We get that upward quadratic. Because kinetic energy is proportional to speed squared and mass, it's always positive, because speed is always positive and mass is always positive. So it's always going to be a number greater than or equal to 0. It's only going to be 0 if you're not moving. But that's it. It's just 1/2 mv squared. That's an important formula to have memorized, just like the momentum formula. Let's do a quick basic calculations using the kinetic energy formula. Find the kinetic energy of a 4 kilogram object moving at 10 meters per second. So we're going to do kinetic energy is equal to 1/2 mass times speed squared. And we have all of our givens. 4 kilograms is our mass, 10 meters per second is our speed. So our kinetic energy is 1/2 times 4 kilograms times 10 meters per second, but that velocity is squared. So I can simplify this, and I get my kinetic energy equals 1/2 times 4 times 10 squared. Units are going to be kilograms, meters squared per second squared, which is a joule. So I'm getting 2 times 100 joules, or 200 joules of kinetic energy. Simple as that. Oftentimes we will know the energy of an object and we'll want to find the speed, so let's do a quick example of that. Down here we have find the speed of a 10 kilogram object if its kinetic energy is 2,500 joules. Again, we're going to do kinetic energy is equal to 1/2 mass times speed squared, but this time we're given the kinetic energy and we're given the mass. So our unknown is speed, we have to solve for speed. So to solve for speed, I'm going to multiply both sides by, well, let's divide both sides by 1/2 m, divided by 1/2 m. 1/2 m cancels on the right, and we're left with kinetic energy divided by 0.5 m is equal to v squared. To solve for v, I just need to take the square root of both sides. And the square cancels the square root. We're left with v is equal to the square root of kinetic energy over 0.5 m. And another way of writing that is square root of 2 times the kinetic energy over the mass. So we plug in our numbers. Square root of 2 times our kinetic energy is 2,500 divided by our mass is 10. So I'm getting root of 5,000 over 10, which is equal to root of 500. If you plug that into a calculator, we get 22.4 meters per second is equal to our speed. We didn't have to do any converting because everything is already in base SI units, so I know that my speed is going to come out in base SI units. That's all for kinetic energy. Proportional to speed squared, KE equals 1/2 mv squared. Hope this is helpful. Bye.